Yeah, so we are now going to concentrate on quantitative decision making, where we will use management science. Management science uses quantitative technique, and when we follow this type of decision making, there are clear cut steps, and that is one course learning goal, that each student should be able to convert the problem into a mathematical problem following the steps. The first step is to define the problem. Okay, first step is to define the problem. Then the second step is to we will define the problem. Then modeling is a very important step, modeling of the problem. So that's the second step. The third step is to analyze the problem and decide which management science tool or OR tool we will apply in this problem to solve the problem. And then finally, we get the answer, and we can easily decide which alternative we can use to take the best decision. And best decision, again, just for a revision, quick revision, you already know. Is there any comment? Okay. The best decision of the manager is to utilize the resources in the best possible manner. So, you can take qualitative approach or the quantitative approach. You work in any department, this is the thing, this is the task of the manager. At the operations level, we will take the decision which will be helping us in utilizing the best way possible, optimal use of the resources. Now, let us come to our topic, that is a very important topic in the steps. And that is to create the model of the problem, to create the model of the problem. And to be precise, when we say management science, it is the mathematical model of the problem. So, we can think of an example, the example of Marriott Hotel that we did. What was the problem? There was a revenue management system, there were variables, there were constraints, and the hotel has to decide how to develop a pricing system, so that the hotel can create a system, so that the hotel can make the best pricing and also ensure that all the constraints are satisfied. So, that was the problem, and the solution was they used some computer system, software system to solve the problem. But in between, the person who did it, he must be both IT, he was mainly be an OR expert who worked with the IT and solved the problem. So, in the solution, in the stage of solution, the first step was to create the model of the problem. So, that is what we will learn today. What is a model? Bina and namuzaj, and we will focus on the mathematical modeling. You have already done this in earlier classes, even in business mathematics, and even earlier, even when all of you are science students, you have come from science stream, isn't it? And you know about, you have already solved general mathematical problems. So, when you grow up, when you go to higher classes in the school, you learn about formulae, you solve problems using formulae, you have some algorithm to follow, yani the steps to follow, and then you solve the problem. That is in a way the modeling of the problem. So, let us start today's discussion on model. Pay attention, very interesting. So here are the 4 steps. So you have to memorize these 4 steps in the management science or operations research problem solving schema. So that's your first lesson for today. Memorize these 4 steps. What are these 4 steps? Number one is to formulation. Formulation means what? Formulation means to convert the problem into for in a different way. So there was a full problem of Hotel Marriott. The manager was not an expert in OR. They gave you a problem. See, this is the problem, and I want to create a system. I want to create a new system for the group pricing. Tell me how to do. So that was his problem. But now, when it comes to the OR side, they will have to formulate the problem in a new way to understand. And formulation means what? To define the problem. Defining the problem, identifying the variables and the constraints. Because earlier, suppose if I say I will give you a full statement, like when you start from your home to college, it takes 1 hour and the distance is 100 kilometers. This is your statement. Now I ask you to tell me what was the speed. What was your speed, Surah? Now what will you do? You will rethink on this problem, define the problem. You will take out important parts. You will take out the distance and you will take out the timing and then find the speed. How do? You will divide the distance by time. So distance is 100 and time is 1. Your speed will be 100 kilometers per hour. So that is how we do in the mathematical problem solving in the OR. Any problem, whether it is marketing, sales, finance, accounting, when it comes to the OR, we will have to redefine the problem in mathematical terms, meaning from the problem we have to take out those information which are important in solving the problem, because everything will not be important. Only the important parts will be those which will be helpful in modeling, which will be helpful in applying the mathematical tool. So that's the first part. Then comes the next important part, that is modeling. Now in modeling, what is done? What is modeling? It is the designing or arranging of the factors or variables. Designing or arranging the factors. Suppose here, as I said, distance and time, these are 2 factors to find out the speed. So distance and time will give us the speed. That is called modeling. This will become more and more complicated, as you saw in the case of Hotel Marriott. There were so many factors. And they were to be arranged to find out the best system for solving and finding the pricing mechanism. Then comes the third step. The third step is to decide which tools of management science or OR can be applied here to find the solution. So there are many tools. Some of them you learned in the example of Hotel Marriott, like linear programming, simulation, or transportation method. So there are a list of tools which are available. Like in mathematics, what tools do we have? Multiplication, division, algebra, simple equation, quadratic equations. So those are all tools. We cannot apply everything everywhere. We have to decide. Only when the problem comes, like if there is a triangle and we have to find the area, we will apply geometry there to find the answer. So here also, once the modeling is done, we know which tool will be applicable to solve the problem, and accordingly, when we apply that tool, we reach the last stage, which is the solution. In the solution, again, you remember the basic definition of decision making. What is decision making? It is the selection of two or more alternatives. If there is no choice for a person, for a manager, only one alternative is given, then these all exercises are waste. There is no other option. You have to choose that. The only thing you can do is how to best do that thing, which will be outside the scope of mathematics. How best to do it? You have to just do that. There is no choice. You have to just decide that option. But when you have more options to decide from, because suppose you have 3 products, you are producing 3 products in a company, and you have the same factory from where you produce the 3 products. Each of them give different profits. Now we have to decide how many of each products to produce from the factory. Here we will apply OR to decide which one is the best option, and we will choose how many of this item to produce, how many of the second one, how many of the third one, and why are we choosing this one? To maximize the profit from the same factory. So these are the 4 steps in problem solving, and we are today trying to learn the second step, which is the model. I just wanted to give a general understanding of a model so that you have some picture in your mind. It's not vague. This is a model of a masjid. It's a model of a masjid which an architect or a designer has designed. Based on this model, the actual construction will take place. And this is very common, you know that in the construction, in the infrastructure, in the real estate, first the model is created, and that is also a very important part of construction. So we want the engineers, or more specifically people in the College of Architecture. There is a College of Kulliya Architecture. I don't know what is the Arabic for architecture. Those people are expert in designing. So they will make a design of the building, of the complex to be constructed. Based on that, there is someone who has translated. Let me just see. Handasa Muammariya. So these people, they are expert, and today with the use of computers, it has become very much easier and also much sophisticated. So engineers can now create very 3D designs, and you have computer softwares. You can get trained in AutoCAD, and there are so many softwares to help create pictures like this. And then on the basis of this, the actual construction is done. So what is this? This is a model. This is a model of the actual plan. Now once the model is created, it is very easy for anyone to start constructing based on this type of a model. So this is a physical model. This is called a physical model, which you can touch, you can see, and this is an example of a construction of a building. But on the extreme other side, there are mathematical models. Mathematical models cannot be seen. It's not a picture. It is a set of numbers and variables, x, y, 1, 2, 3. So that is another extreme, which doesn't have any picture. If you start looking for 1 and 2, it's not there in the around you, isn't it? If I say, okay, tell me the distance, speed of your car, you say distance is 100 and time is 1. Where is it? These are all, what we are calculating is not seen, it's not visible. So that is the other extreme. But on physical extreme, models can also be in the form of pictures. Mathematical models are completely abstract. There is no picture, it's numbers and it's very different. So, what is a model? Now, look at this picture, your lesson number 2 for today. If somebody asks you what is a model, how do you define? If you remember this picture, it will be very easy for you to define a model, and also link it with OR, link it with operations research, because you should not lose the objective. At the back side of your mind, keep that OR always there, because our objective is not to learn engineering or architecture. Our objective is to learn what we are learning, is it making sense, is it really applicable in OR. So, here when we say model, this is a general definition of the model. What we are seeing here, there are 3 pictures. One picture is a irregular shape outside and the color inside is gray. Then inside there is an irregular picture and it is in white. There is an arrow which is pointing outside, and then after the arrow has been pointed, you have a rectangle which is called model. Now, apply your mind, view this picture, because it is very important to understand what is a model. It may be a mathematical model or a physical model, it does not matter, but both are taken out from, it is an imagination. A model is an imagination, it is not real. Model is not real, clear? Model is not real, it is artificial. You create it, like for example, you saw the video of the history of operations research. The first time you heard about model in that video, when the British Army, they created a model of the sea, where their ships were being hit by German forces. Then they also created a model of the aircrafts, and they were assuming, they did a simulation to create a model, what will happen if Germany hit British forces. So, they modeled it. So, what is the model? It is an artificial man-made picture of the real world. So, first of all, what does irregular shape mean? Irregular shape means that it is less controlled, it is real and it is less controlled. It is very difficult to define, because there is no corner, there is no straight line in an irregular shape, whereas in a rectangle it is very easy to measure the area, to describe its shape. It has corners, you can divide the rectangle into several halves, but in an irregular shape you can do much of mathematical calculations on irregular shape. So, what is model is? Model is an abstract representation of the reality. And how is it done? There are 3 steps. Number 1, when we have to solve a problem, any problem, think of any business problem, business operations problem, we have to solve it. There will be a real problem existing in the real world. So, it may be a department where you have to increase the production, that is the real world. Now, I have to solve it, I have to increase the production. So, what I will do? It is not possible for me to take care of complete system, but I am only taking a part which I have to solve. So, I focus on a small part of the real department and study it very carefully. That is called the assumed real world. I take a sample from that real world. For example, there are 100 centers of McDonald's across Saudi, and we want to increase the sales. That is the real world, but it is not possible to work on all the 100. So, I take up one sample or 2 sample, take it out and study it carefully, and then create a model out of that assumed real world. So, the third step is to convert the problem into a controlled system. Controlled system means what? I am excluding some of the variables, I am only picking up some variables. For example, you are sitting in your rooms, maybe classroom or houses. If I want to increase your efficiency, I want to increase your learning efficiency. So, what are the factors I should control? So, your real system is your houses, your room in which you are sitting. Maybe I don't know, where are you now? Are you all in houses or outside also? Some of you might be traveling, some might be in the car. How many of you are in houses right now? All of you are fil bayt, buyut, or some are outside? All of you are right now taking classes from your houses, or some of you are somewhere around outside your houses? Yeah, okay. Mohammad Hurab is in his house taking class from house. But yeah, of course, some of you might be outside your houses. So, what my challenge is to increase the learning efficiency of students in this system, online system. Now, there are 24 students right now. They are all in their houses in different conditions, and now I have to pick up a sample of students from their houses. What are the factors affecting the learning? It may be lighting, temperature, your concentration, your room size, etc., etc. Hundreds of factors would be there, but I will not be able to handle all of them. I will pick up those factors which are really important for your learning, and then I come out, make the model and say, okay, these are the factors which are very important for students' learning, and I have to improve them. So, I have to find out how to improve these factors, and if I improve these factors, like where you are sitting, are you sitting on a static chair or a revolving chair, are you sitting in proper lighting conditions or not. So, these are the factors. I arrange all those factors in a way that your learning efficiency is increased. This is modeling. So, this can be applied, this process can be applied in any type of problem, any type of business problem. It may be sales, it may be increasing the sales, it may be increasing the advertising effectiveness, or whatever. Wherever there is operations, we can apply this process and do the modeling. So, what did we learn? What is modeling? First of all, I am just making it simpler for all. First of all, model is, tell me, is it real or not real? Model, is it the real picture or unreal picture, artificial picture? Let me see, what did you answer? Not real, very good. So, model is not real, but where does it come from? It comes from the real world. And how do we make it? We make it by assuming something, assumption. Is it clear to all of you, this word? Do you know what does assumption mean? Assumption, qiyas, isn't it? Qiyas or what? Assumption. Let me just translate it and see. Assumption, and if you can quickly do it, then my problem will be solved. Iftirazat, yeah, you are right. I will just check myself also and tell you. Assumption. Yes, iftiraz, you are right. Iftiraz. So, it is unreal, but we assume it from the real world. So, I gave you an example of a classroom. You are sitting in your houses taking the classes, and I want to improve your learning. So, if you are learning, suppose it was 8 out of 10, I want to make it 10 out of 10. So, what to do? How will I do this? Now, here I will apply OR and try to increase your efficiency, and for that I will have to do modeling. So, the modeling, first of all, I look at your real world. So, there are 24 students. I know that all the 24 students are located at this place, but it is not possible for me to take care of all the 24. So, I will take sample of 10 or 5 and then from that I will pick up the factors and make a list of the factors which are very important for your learning, and then improve those factors. So, your lighting, I will increase your lighting, I will increase your sitting conditions, sitting posture, I will ensure that nobody is lying in his bed and taking the lecture, all of you are sitting like in your classroom, and these will be the factors, but model is not real. So, that means some of the factors I have not taken into account. So, model is an abstract representation of an existing problem situation. It is a functional relationship that includes variables, parameters and equations, purely for mathematics, in the form of a graph or chart. Okay, its model is also in the form of a graph or chart, or in the real picture also, like the masjid model that we saw. But for mathematics, we are concerned, or we will be dealing with functional relationships, including variables, parameters and equations. Each of them we will define shortly in the slides, but right now just try to memorize and understand the definition and concept of modeling. It is the abstract representation of an existing problem situation, and mathematical modeling means that we have to convert the problem into a set of variables, a set of parameters and equations. Once we are able to do this, we can easily solve the problem and decide what is the best source of profit. How can they be? How can models be? Models can be of three types mainly. One, they can be iconic or physical, like the building just we saw, masjid. It can be abstract, like mathematical in OR, the model that we will be using, or somewhere in between. Yani they may be having some mathematics also and some picture also. So, these are the three types of model. This is just for increasing your knowledge on modeling. We are trying to understand slightly more than required. So, this is how the models look like. If you scale it, if you put it on a scale of exactness, yani reality, to abstractness, unreality, it moves from left to right. Physical models are the most exact. So, when you have the picture of the masjid, model of the masjid, and the real masjid when you build, both of them will look very much the same. Similarly, you construct so many buildings, the model and the building looks the same, but when you look at mathematics, it is not the same. You write some formula or equation to solve the problem, but when we actually solve the problem, it is real. So, I change your sitting positions, I do it mathematically, I say okay, I calculated if I change your sitting position or looking at the computer by 5 degrees, then your learning efficiency will increase by this much. Now, what will I do? I got the solution, I will change your sitting positions. This is really done, but the modeling was abstract mathematics. So, this is just for information. There are mainly two types of models: physical exact and mathematical abstract. In between, there are many types of modeling: scaled, analog, management games, computer simulation. We should remember this. Okay. Now, let us come to our model, which is which we are going to do in management science or OR. In OR, you already learnt that it is a mathematical model. So, tell me, is it where does it fall? Is it a physical model or an abstract model? Is it real or abstract OR model? If you understood what we discuss now, you will be able to answer me. OR models are physical or abstract? The tools that we are going to use, we are going to apply OR model. Now, OR modeling falls in which category? The physical category, iconic, where we see the real picture, or it is on the mathematical side which is abstract, which is unreal. We don't see the real picture. What do you say? This should be clear. No? It is abstract. So, this is very important for you to learn that the OR model is mathematical model here, mathematical. So, we fall in this side, mathematical side, which is we don't make picture of the model, we make equations of the model, formula of the model and solve it, right. So, this is clear. Okay. So, OR model consists of a set of mathematical relationships. These relationships are made up of numbers and symbols, as we do in mathematics. A plus b whole square is equal to, similarly, what is the area of circle, pi r square, so on and so forth. So, in the operations research problem solving also, we will convert the problems into simple mathematics, not very difficult. The most important part of OR problem solving is the algorithm, to learn the steps of solving the problem. If you learn those steps, mathematics is really easy in that. So, the next point, and which is the most important point to learn, is how to write the general OR model, operations research model. Pay attention, very important, all of you. This is the mathematical equation or the general operations research model. What is it? It says maximize or minimize objective function subject to constraints. This is the general OR model, and this is what we are going to apply. Whatever tool we use, whether it is linear programming or transportation or simulation or game theory, we are going to use the same model. So, let us look at each of the items very carefully. Listen very carefully, because you have to understand this. Otherwise, when we start solving the problem next week, if we are able to complete this today, then we will start with transportation problem in the next class. Okay, modeling looks like how we imagine the final. Very good. Yeah, modeling looks like how we imagine the final part of problem solving, not the final part, the part just before the final. Just before the decision making, we have to create a model, we create a picture or an equation, and when we apply the tool, for example, just look at the picture of the masjid. It is a model. Now, what you should do to create the real? You have to apply the engineering. You have to whatever engineers learn in their civil engineers, they learn in their classrooms. They will come and apply those tools, because the model is only a picture, is only a collection of the factors, the size of the land, where symmetry of the land, and where all things can be done. And the engineer, the architect, he created the model. Now, the engineer will apply his skills, like you business managers, you will apply your skills to solve the problem, to take a decision. So, it is a step before the final decision. It is a step before the final decision. It helps in taking the final decision. So, now let us look at this equation. This is the general OR model: maximize, minimize, both are in red, objective function subject to constraints. What I will do, let me first just explain this equation gently, in general way. Listen carefully. I think this is very easy. None of the words are so difficult to understand. It is easy, but you have to pay attention, and if you do not pay attention now, rest of the chapters will be very difficult for you to understand. Maximization means what? To increase or decrease? Maximization, what does it mean? It means to increase or decrease. Let's see. Okay. Increase, very good. So, what do we maximize? If I tell you to give me an example of maximizing in the business, what do we want to increase? Very easy. The first answer will be what will be products. You want to increase products, maximize products. That's not right. What will you like to maximize, increase in the business? Look, think from operation, profit. Yeah. So, the first target, first general target for any manager will be to maximize the profit. What else? What else can we maximize if you are business students? Because profit everybody knows. Even if you are not a student of business, even that person can tell you, I want to increase my faida. What about others? Like efficiency. I want to improve the efficiency of my company. I want to increase the efficiency of my human resource. I want to increase the production capacity of my plant. These are all maximization. Now, let us come to the minimization. Now, again when I say minimization, it is decrease. So, what does a manager generally have the goal of decreasing? What would you like to decrease? What is the general example of decreasing or minimizing in a business? Tell me. Problems in the company. Now, these are all very general. Think more technically. Think more technically from a business, real business problem, operations problem. So, a problem, fraud. Okay. So, you want to reduce the fraud. So, that is fine. You want to reduce the number of frauds in your company. That is fine. Else, what do you want to reduce? You reduce the cost of the production. You want to reduce the cost of production, cost of labor, cost of energy in the company. You want to reduce wastage. You want to reduce employee turnover, employees leaving your company, you want to reduce. So, these are all examples of minimization. Let us come back to the slide. So, you understand that in a company, either there are only two options for a company, every operation. Either the objective may be to improve, increase or reduce. So, improving in generally, in technically everywhere across the book, in this discipline, the word is maximization and reducing is minimization. There is a common word for both of them in order to make it simpler or make it one. There is a one word which includes both maximization and minimization. Anybody in the class can give me that word? Do you have any guess? This is a general word, everybody knows it. You must have heard of this word. What is that word which includes both? Either it is maximization or it is minimization. It can be applied to both. What is that word? Who will tell? Any guess? Balance. You are close. Can you think of any other word? Okay, I will give you one choice. It starts with O. Think of think from technology perspective, from business, and you must have heard this word very often in business different courses. Very good, mashallah, quest, optimize, excellent. So, the word is optimize. So, I think you need some, let me see if I have something to give you as a gift. I don't know, it will take a, so maximize, some other student can give you a gift. Maximize or minimize, both of them have one common word, that is optimize. Optimize takes care of both. If I tell you this is an optimization problem, so you should not conclude that it is only maximization, it can be minimization also. So, if I tell optimize cost, what do you mean? It is to minimize the cost. If I say optimize the profit, it is to maximize the profit. So, that is one word for both maximization or minimization. Let us come to the next part, which is objective function. Now, objective function means what? This is the goal. This is the goal. Goal is to maximize or minimize, and subject to. Now, the question is, this was a question I asked you in the quiz, and we discussed in the class also many times. Every organization has limited resources. We all agreed on it. Limited resources. Yani, even though it is the biggest organization of the world, or it is the smallest organization of the world, resources are limited. Limited time, money, materials, labor. That limit or limitation is called constraint. There can be other limitations, like limitations of time, limitations of labor, limitations of money. Within this limitation, you have to perform, you have to optimize. I can teach for 2 hours, and the efficiency of the students can go up, but the time given to me is only 1 hour. What is that? It is constraint. So, my constraint is within 1 hour I have to teach in a way that it increases the efficiency of the students, that is optimization within constraints. So, constraints you understood, limited resources. Okay. Remember this, constraint is limited resources. If there are unlimited resources, okay, he gave himself good. Limited resources, constraints I am writing here, you can note down because it is not written in the slide. Constraint is limited resource, okay, equals constraints. So, you understood this? This is the general equation. If there is no constraint, no limited resource, again what can be the limit to minimize or maximize? 100%. You can maximize the profit to indefinite, keep on producing. You have a plant and you can produce unlimited quantities. So, your profit will be unlimited. You can reduce the cost. There is no limit on example, you may be able to even work with 0 labor, but that is not physically really possible. 0 labor is not possible. You must have 1 labor, 2 labors, and when you have labor, you have a worker, you have to pay him. So, if you pay him, what does that mean? There is a cost. So, there has to be cost. So, when there is a cost, your profit will be also not 100 ever. So, there is always a resource constraint. So, constraint is limited resource. I will come back, I will ask you this equation again and again for several lectures. Okay. So, you have to memorize this, maximize or minimize, objective function, subject to constraints. Now, in this equation, you said maximize or minimize objective function. Now, this objective function, when we come to mathematics, when we say any problem solving, we have first of all, what are we going to solve? Is there anything to solve in a constant, or anything can be done in variable? Obviously, you all may be knowing, where can you make changes? Suppose I tell you, I ask you a general question, listen to me carefully. In which of these can you make changes, in variables or constants? In mathematics, these are very common terms, variables and constants. Let us just look at in the dictionary also, what is the Arabic term for variables and also for. So, variables are al-mutaghayyirat, okay, and constants are, what is constant called? Constants are thabit. So, you have two mathematical terms, one is al-mutaghayyirat and the other is thabit. Now, the question is, which can be changed, variables or constants? You can make changes. Any, are you there? Tell me. In which of these you can make changes, in variables or constants? Suppose I tell you, you have to go to Taif, which is 100 kilometers from here, and you have to keep your speed at 100 only. So, what can you do? It is a constant, you cannot change the speed. So, what will happen? You will reach, no matter whoever goes at 100, you will reach the same time. But if I tell you, you are free to change the speed, you can go up to 120, 60, you are free to change variables. So, variables can be changed, and these are the objective functions, these are the variables, these are the functions which we can manipulate, which we have the option to manipulate in the problem, in the business problem, and we can increase or decrease the profits or the objective function. So, the maximization or minimization can be done by working on the variables. So, variables are very important. So, the first thing, when we are solving the problem, we will have to look for variables, things that can be changed. So, when a problem comes to you, you are a marketing manager, a problem comes to you, and you are you have also learned OR. The first thing you will do in marketing operations will be, the problem will be to find out the variables, those factors which you can change. Suppose the timing of advertisement, when can you place the advertisement, what time, in the morning, in the evening, in the late night, and you know that if I place the advertisements in night, the efficiency is more. So, it is a choice, it is a variable, you can do that, but you cannot change the cost. Cost is to be kept constant, you have to only spend 10,000 reals on your advertisement. So, that is constant, but the timing is variable. Similarly, you can apply this in anywhere, but the core concept is the same. Variables are those items in a mathematical equation which can be changed, which can assume different values, and it is represented by a symbol A, B, X, Y. So, in your schools, suppose I do not know, I am not very aware of school maths, how you do. So, in mathematics, in Riyadiyat, what do you do? Variables, with what letter do you use English letters or Arabic, alif, ba, etc. to denote variables? You use what letters do you use? Huruf, fil logal English, okay, A, B, C, etc. right? A, B, C, X, Y, Z, etc. Okay. So, that is variable, and constant are those values which do not change, which remain same. As I told you, you have to go to Taif, but your speed must be 100 only, you cannot change. What you can change is the timing, or you can change the destination, and you can take a shorter route or you can take a longer route. This is not constant, this is variable, but the speed I have kept constant. So, the variables are those values which can be changed, and there has to be variables in your equation, otherwise how will you maximize and minimize? So, there has to be items in our problem which can be changed, and there are many items in the business problems which we can manipulate, we can change. Accordingly, the result will be maximization or minimization. Now, let us come to the second part, which is two types of variables are there. One is dependent variable and the other is independent variable. Dependent variables are those which are dependent upon some other variable. So, objective function, like I have to increase the profit, but how will I increase the profit? Profit is dependent upon, what is profit directly dependent upon? Tell me, what do you say? Profit is the result of what? Of profit is not an action, profit is the result, natija. But what is the action? Amaliyat, which results in profit. Tell me. How will you get profits? It will be the result of buying and selling. That means, if I make it more precisely in mathematics, income, sales revenue, or production, selling, selling units. So, what does it mean? It means, now tell me, think properly. I have two items, one is profit and the other is income, sales income. Both are changing. Listen carefully. Sales income is also changing. Daily basis it changes. When you advertise more, sales increases. When you give promotions, sales increases. When sales increases, profit also increases. So, which is dependent variable? Is it profit or sales? Revenue, sales revenue. Which is dependent and which is independent? What increases itself? Selling, and the result is profit. So, in dependent and independent variable, what you should understand is that one is the result of the action, one is the result of action. So, as I gave you the example, dependent is profit and independent is sales revenue, meaning sales affect profit. So, this is a very important concept you have to understand. Both change. Since both change, they are called variables, but one is dependent upon the other. Profit will increase only if the sales increases. So, profit is a dependent variable and sales revenue is an independent variable. We use X, Y, Z, A, B, C to denote them in the equation. Let us come to the second part. There is also called something called parameters in OR. Another word for parameter is constant, constant which will not change, which has to be fixed. And for example, as I said, suppose I want to increase my profit. How will I increase? By selling more. But how much can I sell? How many products can I sell? Tell me. Is there any limit to production or it is unlimited? What do you say? Is it unlimited production in any company or there is a limit to production? And what is the limit? Unlimited, really? La mahdood production in a company, or there is a limit? What about others? Sultan, Imran, Sultan and Muhammad Hureb, Salim. What do you say? Is there, when you are producing goods or services in a company, is it unlimited production or limited production? And what does it depend upon? And it depends upon what? The size or capacity of the plant. So, you have a teacher in your classroom, one teacher in your college, and he has to teach the students. So, is there a limit? Yeah, of course, there is a constraint. He can only teach 5 hours daily. Now, what will you do? If you want to increase the number of classes, you have to increase the number of teachers, because this is fixed, constant, one teacher 5 hours, not more than that. So, this is called parameter, this is called constraint. So, in the equation we have to find out what is changing and what is fixed, what is changing and what is fixed. So, those which are changing are called variables, those which are fixed are called parameters or constants. Examples are clear to you, parameters like plant capacity, the worker capacity, workers can work only 12 hours daily or 8 hours daily. You cannot ask them to work more than 8 hours. So, these are parameters, these are the constraints, you cannot, these are constant values, this will not change. Now, the last point, feasibility of the model. What is the feasibility of the model? When you say that the model is feasible or the result that you have found which you say is optimal, yani the maximum or the minimum for the problem is feasible. Feasible means what? Feasibility in general means is it real or artificial? Are you just guessing or is it mathematically possible? Meaning, suppose I will say jadwa, feasibility jadwa, or is it right? Feasibility is jadwa, possibility, imkan. So, the question is, I am telling, my manager tells me I want to increase the profit to 100,000 reals from 5,000, and this is my plant capacity, this is my production. I will look at the variables and constants and then I will tell him, yeah, it is possible. But actually the truth is it is not possible, because the plant has constraints. The constraints are, this is fixed, the plant capacity is fixed, the per unit cost, per unit sale, per unit profit from or per unit income from any sale is fixed. So, did I take into account the constants and the constraints or not? So, when I say that I can increase the profit from 5,000 to 10,000, have I taken into account all the constraints of the problem of the business? What are the constraints for any business company? The constraints may be time, may be income, may be money, may be manpower. So, these are the constraints and these are supplied to us by the company when we are solving the problem. They tell us, see, these are the constraints and this is the variable, these are the items we can change, these are the constraints within which you have to change. So, feasibility of the model is, you have to today, when we do the problem solving next week, it will become clearer. You have to memorize these. Feasibility of the model, if all the constraints are satisfied, and constraint we just defined resource limitation, limitations on the resources. If you say I want to increase my profit from 5,000 to 10,000, then I will tell you how much money do you have to produce. Do you have 50,000 reals to spend on raw materials? Do you have 50,000 or 10,000 reals for labor or not? If you do not have that money, how can you increase the profit from 5,000 to 10,000? So, you have to tell me what is the level of money you have, what is the number of manpower you have, and those are the constraints within which I will decide. I will tell you, is it possible for you to increase the profit or not. Once your problem is solved, taking into account all the constraints, it is called the optimal solution, which may be maximization or minimization. This yields the best value of the objective function. So, this is the best profit or the least cost or the maximum profit or the minimum cost that is possible for this company with the constraints, because you only have 10 labor, you can only produce this much can be your maximum profit. You have this much of time, this is your production, this is your profit. This is called optimal solution. So, what did we see? Let us look at it again. General OR model, this is the definition or the equation you have to remember. Then the parts of the model we have to remember very carefully, what is variable, what are parameters or constants, what are constraints, we already did it, and feasibility of the model, and finally, the optimal solution. The relationship between the variable and the constants are called functional relationship. We do not want to go into much detail into this. This is general, you have to just, it is mathematics, a plus b is equal to what. So, this is called equation. So, in the just what we saw, this is an equation, this is a mathematical equation showing the functional relationship between constraints and resources. Now, let us quickly look at two very simple examples, and we will then stop. Number one, listen carefully, very interesting and very easy. I cannot think, this is in your book. So, it cannot be easier than this to explain all the things we have learned so far. The first example, listen carefully. There is a business that sells a product, think of any product. The product costs Saudi Riyal 5 to produce and sells for Saudi Riyal 20. Now, this is the general costing and selling price. Selling is 20, costing is 5. So, you have to create a model that computes the total profit. How will you do? What is the, let us look at, it is a very simple problem. You already know that the profit is 15, but we have to create a model so that any number, we can change the number and the result will be the same. So, what is the main item variable in this? What are the constants first? So, the constants or the parameters, listen carefully, the constants or the parameters in this, let me explain here so that it is clear. Let us look at for variables in this problem, then constants in this problem, and then we will create an equation. So, what are the variables in this problem? What is the main variable in this problem? It is the number of units of products produced. So, that is the main item that can be changed. So, if I produce one item, what will be my profit? I make the product for one product for 5 riyals and I sell for 20. So, what do? I will simply say that selling price minus cost price is equal to profits, simple. Now, selling price, how do we calculate? Selling price per unit multiplied by number of products, and cost price again it is the per unit which is given multiplied by number. So, this way if we know these values, these are constants, per unit is given, per unit selling price is 20, you cannot change that, it is called constant. Per unit cost price is 5, this is constant. And what we can change? We can change the number of products. So, number of products, how many can we produce? We can produce 100, 200, 300. Is there any limit on production in this problem? That is what I want to know from you. Look at this problem very carefully and tell me, is there any limit on production in this problem? Yes or no? In the problem, in the question here, is it written that how many number of products you can produce? Yes or no? Let us see. No. All of you understand this? All the students, do you understand that in this problem variables are given, variable is the number of product, constant is given, constant is the selling price and the cost price, but there is no constraint, there is no limit on how many we can produce. So, the equation is simple, the model is simple, we will simply write down this problem as this, selling price minus cost price is equal to profits, and selling price we will make by multiplying the parameter or the constant by the variable, constant by variable, and we will get the profits. So, this is the first. So, you understood this is what this is constant Saudi Riyal 5 of production cost, this is constant. What is the variable? Variable is the number of products which will affect the profits. So, if I produce just do some calculations, let me ask you a question. If you make 1 unit, how many profit? What will be the profit? If I make just one product, what will be the profit? I will simply put the values here and get the answer. So, if I make 1, suppose I make just 1, what do I do? 1 per unit is 20 multiplied by 1, that is my cost, that is my sales, and then cost price is 5 multiplied by 1. So, I get my profit, that is 15, 20 minus 5, 15. Now, I change this, I say I want to produce 50 units. So, what will you do? What will be the answer? The formula remains the same, the model remains the same. I will just have to, so here this number I will call it x, I will call it x, this, so that it is more clear to you. This is the variable x, this is also x. So, if I give you the value of x, 20 into x minus 5 into x is equal to profit P. We write this P generally as Z in operations research, and when it is profit we call it Z max. So, this is the general equation for this problem, and when you get the value of x, the variable, we can just put it in the equation and we will solve the problem. Okay. This is called modeling, this is called mathematical modeling. Now, let me ask you, if I give you 50 x, of course, x means number of products and it is a variable, x means number of products. Yes, I will write it here. You can take a screenshot of this, and also I know it will be there on YouTube. I will upload this, so you can check there also, but for quick writing you can just note it down. This is the number of products x. So, all of you understood in this problem what are the constants or parameters. The other name for constant is parameters. You do not have to calculate constants, the company will give you, or in the problems that we will solve, we will get the constants. You understand the equation. So, what is the, tell me what is the other name, more technical name of the equation? 20x minus 5x is equal to z. What do we call now this one? Who will answer this? What is the more technical name in OR for this equation? Who will answer? I will see if you followed the lecture properly or not. Tell me, give me a technical word for this equation in the problem of profit. What should we call it? No? This is the model. Okay, this is the model. So, an equation is more technically called model in our case in OR, and what we have done, we have modeling. So, we have converted the equation into the problem into a mathematical equation, which is a model for us. Now, that is first case. The second one, it makes it slightly different. So, we will copy everything from here and paste it, and then we will stop after discussing that. That will be the last thing. Look at this problem. It says, in the same problem, let us assume that the product is made from steel and the business firm has 100 pounds of steel. If it takes 4 pounds of steel to make each unit of the product, then what will be the answer? Now, here there is a problem. It is not unlimited, this becomes limited. What is the limited resource here? Tell me, what is the limited resource which the company has? The company has limited amount of steel. How many? Only 100 pounds. So, what happens? Only 100 pounds. So, this is the constraint. This is the constraint. So, the material steel is limited. We will not solve this, we will just leave it like this. But what will happen is Z max will be subject to the value of x cannot be more than, cannot be, it has to be less than how much? 100 by 4, 25 only. Number of products, how many they can produce? One product needs 4 pounds and the company only has 100 pounds. So, what happens? The company can only produce 25 items, not more than that. So, that is a constraint. X can be only equal to or less than 25. Now, we have to solve the problem. So, what does it come? 20 into 25, 500 minus 5 into 25, 125. That means the profit can be at the maximum 375, not more than 375 reals. So, what happens here? The main difference between example 1 and example 2, this one is a case of unlimited without constraint. This is an example with constraint, which is our main type of example in OR. Z max is subject to constraints. Z max is subject to constraints. You look after these problems, go through them again later in your free time, ponder over it carefully, and when in the next class we will start solving transportation, we will start with applying the OR tools, but the general equation etc. remains the same. That is it for today. I stop the recording now and this will be available to you